Hello everyone, I'm very happy to be speaking at this Pulsar Summit Europe. My name is Christophe Bornet and I'm a senior software engineer at DataStax. I work fully on Apache Pulsar and I'm an Apache Pulsar committer. Today I want to talk to you about Pulsar Transformations, which are an easy way we provided to build data pipelines using local declarations. And so I would like to start by telling you how it began, because there's a story behind this. It first started with the way we transfer data from a database to another database using Pulsar. So classically, we do this by using a source that will read from the database, the data from the database, transform this into messages, and put the messages into Pulsar. Then you have a sink that will read the messages from Pulsar and put them into the other database. We had a user that came to us and said that he wanted to get its Cassandra data and work on it from AWS. So for this, we would need to transfer the data that was in Cassandra into AWS. The solution for this was to use existing pieces that we had at the moment, such as the Cassandra CDC source. So CDC stands for Change Data Capture. Change Data Capture is a technology that watches the changes that occur on a database, and each time there's a change, so an insertion, modification of a row, then it creates a message and puts it into Pulsar. And then with the Kinesis sync, we read this message and we publish it to Amazon Kinesis. At the time, on the Kinesis sync side, we had a few possibilities for the output format of the message. The first one was only raw payload, so in this case it was the raw bytes of the payload that were published to Kinesis. There was also the possibility to have the message, full message in JSON, but actually it was a JSON structure which was containing the payload and the properties, but the payload was still the raw payload, the raw bytes of the payload encoded into base 64. There was also a possibility to do the same with flat buffer. So the problem with that is that CDC sends Avro messages, and actually it's a key value Avro. So it maps the primary key columns of Cassandra to the key to an Avro key structure, and the regular columns goes to the value. And for him, it was easier to work directly on JSON, so he wanted to have JSON. So the first thing we did was to create a new message format for the Kinesis sync that would transform the payload to JSON. If you had key value, there would be a key field and a value field, and then depending on the schema type, we converted the value to JSON. So for Avro, we use a converter from Avro to JSON. So this is how it looks like for a standard payload. You have key A, B, value A, C, D. Okay, so this was the first step, but then he came back to us and said that he wanted to put his data into a data lake. So it would have been easier to work on flattened data, where each key or value would have been a field of the JSON rather than a structured JSON. So we worked on an option to flatten the JSON payload, and we added it to Kinesis. We always wanted to have something generic, not only done for our use case. So this stays generic. If you have a JSON with nested fields, all the fields become first level into the JSON. with naming conventions for the new fields. So this was we put an underscore between each nested type. So here for a value key, for a key value, it would give value C, value D, key A, key B. But the problem was that we still had these headers for keys and values, and so he wanted to have them removed. But we still wanted to have something very generic for the Kinesis sync, so it was not easy to do it without in a generic way. The way to do it would have been to merge the key, to have an option to merge the key and value fields, and then another option to unwrap the value from the key value. So if you merge the key and value, you have A, B, C, D in the value, and then you unwrap the value, so you do not have a key value anymore. It's a standard arrow with A, B, C, D. We also had other ideas that we wanted to have. The possibility to remove sensitive fields if you have a column in Cassandra that you don't want into Kinesis. You want to remove, for instance, the password of a user. Sometimes you want to filter some bad messages. And we also saw that there were the same requirements were coming for other things such as Elasticsearch. So we could have continued to add new config options indefinitely and to do it for all the things, but it was going to be an n-square problem, and so this was not scalable at all, and becoming very complex with all these options. So we needed something better, and we looked at what were the possibilities with the existing technologies. And one that comes to mind is, of course, stream processing engines. So stream processing engines are very powerful technologies that can do a lot of things and are often used to transform and to prepare the data for other systems. So we can name a few, such as Apache Flink, Apache Spark. You can even use KSQL with Pulsar, since Pulsar can talk the Kafka protocol. But the problem with this processing engine is that they are quite complex technologies. They require to deploy infrastructure. There's a high cost of acquisition to understand how they work. Then you have the maintenance burden because there are new technologies that you need to introduce into your stack. And you need to integrate them with Pulsar, which is not always an easy task. The other way would have been to write functions. So you could write a function that prepares the data however you want between your Cassandra database and your Kinesis sync. This has the disadvantage that you need to write a lot of code, and you need to understand how Pulsar works, how the Pulsar schema works. If you want it to be generic, it's even harder because you need to handle all kinds of little quirks. And the other issue is that Pulsar functions, they read from a topic right to another topic. So between the function and the sync, you would have an intermediate topic that would mean an increased latency and an increased cost of resources such as IO. So seeing all that, we said that we wanted a solution that wouldn't require to deploy more infrastructure than what we already have in Pulsar, that would be able to do transformations of data with low-code declarations, so without writing code or understanding the Pulsar schema, etc. And ideally, that we could apply in memory before a sync, so that we could keep the low latency. So this is how we came to Pulsar Transformations, and we designed Pulsar Transformations as a regular Pulsar function. So this way we use all the function management of Pulsar, the life cycle, etc. It's a regular Pulsar function. Everything you have for Pulsar functions continue to are applicable to Pulsar transformations. And these transformations, they have in it they are implemented all the common transformations that you do on your data, and that you can configure with a simple JSON declaration. So when you create an instance of the function, you pass a configuration, and it's in the configuration that you say which transformations you want to apply. We also worked on PIP 1 and 3, which is the possibility to apply a function before a sync, and to do it in memory without going through a topic. So we will apply the function and pass the result of the function to the sync in the same runtime. And this is available since Pulsar 3.0. This can be used with any function, including the Pulsar transformations. This idea of Pulsar transformations is not completely new. Actually, Kafka has it for ages. In Kafka, it's called single message transforms, or SMTs, and this was an inspiration for the Pulsar transformations. Also, although we try to have a better format for configuration than SMTs, because the SMT format is hard to read. At least that's my opinion. Last but not least, the Pulsar transformation it's an open source project, so we want everybody to be able to contribute and use it, and we've published it under the Apache license. So we have I think that we have the most common transformations we've seen in the field already implemented. So you already have the possibility to drop a field from a structured payload. So if you have Avro with fields A, B, C, you can drop B, and you get an Avro with only A and C. You have the possibility to change the schema type of a message. So if you have Avro, you can, for instance, cast to string. This will transform your Avro message into a string, and when you transform Avro to string, we actually do the JSON representation of the Avro. So you get a JSON string of your Avro payload. So we already talked about the merging the key and value and unwrapping, because it's where the functions that were needed for our use case with Kinesis, and also to be able to flatten the structured payload. We have the possibility to filter messages. Actually, there's the possibility to drop messages, and all the operations can be applied conditionally. So when you define an operation, drop a field, cast a payload, etc., you can say when and give a predicate. And so filtering your message is drop message, when, and this is where you give the condition for the filtering. And eventually the possibility to compute a field from another field. So this is a quite powerful feature, because you can do a lot of things. I will come back to this later. So let's see an example of configuration. So when you create an instance of the function, you pass this as your function configuration, and you see that you can define multiple transforms into the same function instance. For instance, this one will drop the field password from the Avro, then merge the key and value, then unwrap, then cast the result to string. So the operations are applied in order. If we look more on the compute operation, so I said that it's quite powerful because it has the possibility to compute key value from other fields, but also it can do it on the metadata of the record. So it's also possible to act on the message properties and on the topic destination. So this means that you can do dynamic routing based on message properties or field values or key values or etc. You can modify the topic destination of your message based on these values. It uses an expression language. So if you're familiar with JSTL, it's quite similar. And we have implemented a few operations such as plus, minus, and, or, equals, not equals, and also utility functions, mostly on strings. So you can replace a string with a regex. You can compare a date field to now, etc. This is an example of a compute operation that will do routing. So we will transform the destination topic, and we get the value of the destination topic from a concatenation of a string routed and the message key. So if your message key is A, the message will be routed to the topic named routed-a. If the message key is B, it's routed to the topic named routed-B. And now let's see how it works with a demo. Yeah. So for this demo, we will create a transformation function that will take messages from an input topic. So I'm creating an input topic. And then for the messages that have a high value, we will output them to a topic named high. And for the values that are low, we will route them to a topic named low. So I will also put a string schema to my input and to my high and low topic. This is because it's easier than to work with the Pulsar client with strings. So for input, low and high. Okay. Now we will create our function. So our function is a routing function. We will name it router. It will take the input topic as input and high topic as output. So all messages come from input, apply the transformation and go to high. But in the transformation itself, we will say that we declare a compute operation. And this compute operation operates on the destination topic. And we say that the destination topic will be the low topic when the value is inferior to 1000. So this means that if the value is inferior than 1000, the destination topic is changed to low, otherwise it stays to the default topic, which is high. Okay, so my tenant is Bornet example, the namespace is default. Also, interesting to note is I'm using built-in so when you deploy the function, there's the transformation function, there's a nar, and if you include it into your, you can deploy it as a built-in nar, just like things or sources. In that case, its name is transforms. So this is what I'm using there. I'm creating the function, and it will take a little bit of time to start. I will create a topic, a consumer for the topic. Let's start with low here, and another one for high. Okay. Okay, so normally the messages with the high value will be routed here, and the messages with a low value will be routed here. Then we can produce to the input topic. I say that my schema, value schema is string, and I produce, for instance, a value that is bigger than 1000. And normally, once it's produced, we can see that it was routed to the high topic. Now let's do it again with a topic with a value lower than 1000, and it's routed to the low topic. Okay, can do it again with a high value. Okay. So thank you for attending this session. I hope you found it interesting and that you will soon start to use the Pulsar transformations. They are ready to be used in production. Actually, we have users using them in production, so don't hesitate. If you have questions, you can reach me on Twitter. So there's my Twitter handle, cbornet_, and also you can check the Pulsar Transformations GitHub repository and open issues there for discussion, to request new features, or if you want to contribute. We really welcome that. And so now it's time for questions if you have, and otherwise I wish you a good Pulsar Summit. Thank you.